Very good morning, children. Welcome back to part 3 video of chapter 6, class 12 physics. And in part 1 and 2, we discussed about the laws of Faraday's laws of electromagnetic induction. And then we derived a formula for motion EMF, and we discussed the energy consideration there. And also we discussed application and what are eddy currents and what are the applications of eddy current. So here now we are going to learn about induction, and there are two types of induction that we are going to learn about: mutual induction and self-induction. So the first topic in this we are going to learn mutual induction. What do you mean by mutual induction and what do you mean by mutual inductance? So first of all, let's have a setup, an experimental setup for explaining this mutual induction. We have a coil. Suppose we have a very big coil with a bigger radius, and we have a very small coil with a smaller radius. And number of turns in the first coil will be N1 and number of turns in the second coil will be N2. And number of turns per unit length can be small letter n. So small letter n1 can be written like n1 upon n, or n2 also can be written like n2 upon n, which is the length of the both the inductors, or हम solenoid भी बोल सकते हैं, right? Coils, solenoids. So the length of both the solenoids be the same. So if you pass a current through the first conductor I1, then we know that there is a magnetic flux induced in the coil, because we have already derived a magnetic field for the solenoid, and the magnetic field was D is equal to mu naught Ni. So it will be like mu naught N1 I1. So that is a magnetic field created by the first coil. So the bigger coil we consider as the first coil. So the magnetic field exists inside the second coil also, because magnetic field is inside of the solenoid. So inside of the solenoid there is a magnetic field, and we have to find what is a flux related to the second coil now. Because earlier there was no flux, and suddenly there is a current in the first coil, and suddenly there is a flux, and that flux even it will pass through the second coil. So so what is the flux that passes through the second coil? N phi. So N phi is equal to B dot A. So B is due to the first one, but area is the second one itself. So area here, the area which is passing through the flux is pi r2 square. So because r1 is the radius of the first one, r2 is the radius of the second one. Okay. So here you are getting N2 into B1 is mu naught N1 A1 I1 into I2 A2. So what is A2? Pi r2 square. Or even you can write simply A1 A2 also you can write, no problem. So that is the total flux passing through this second solenoid due to the first solenoid, due to the current in the first solenoid. So यहाँ पर current जो है ना, the current is flowing through the first conductor. There is no current in the second conductor, the second solenoid. But still, the magnetic field created, it passes through the second one also. So we know that whenever there is a change in the magnetic flux, a current will be induced in the coil. इसका मतलब है जो सेकंड कंडक्टर है इसमें कोई इंडक्शन जरूर होगी, मतलब इसमें कोई करंट इंड्यूस होगा. क्यों? क्योंकि पहले तो इसमें कोई मैग्नेटिक फील्ड था नहीं, और एकदम से इसमें जब करंट पास किया तो एकदम से यहाँ पर कोई नया मैग्नेटिक फील्ड आया. So then there will be a momentary current, है ना? ए मोमेंटरी करंट मतलब करंट चेंज होता है, सो डी फाई बाई डी टी मतलब मैग्नेटिक फ्लक्स जब चेंज होता है तभी, है ना। मैग्नेटिक फ्लक्स अगर चेंज ही नहीं होता तो डी फाई बाई डी टी क्या होगा, जीरो हो जाएगी, सो कोई ईएमएफ प्रोड्यूस नहीं होगी। लेकिन अगर चेंज हो रहा है, फाई इज अ वेरिएबल, देन देयर इज एन ईएमएफ। लेकिन फाई जब तक वेरिएबल है तब तक ईएमएफ है। इसका मतलब है कि जब एकदम से यहाँ पे करंट पास होगा तब इसके अंदर एक ईएमएफ इंड्यूस होगी, इसके अंदर एक करंट इंड्यूस होगी। करंट जो इंड्यूस होगी वो किसके ऊपर डिपेंड करेगा, यहाँ पर जो फ्लक्स है उसके ऊपर डिपेंड करेगा, और यहाँ पर जो फ्लक्स है वो किसके ऊपर डिपेंड करेगा, जो बाहर जो कॉइल में जो करंट जा रहा है। तो आप इस चीज को शॉर्ट फॉर्म में ऐसे लिख सकते हैं कि जो भी फ्लक्स यहाँ पे जा रहा है दैट इज डायरेक्टली प्रोपोर्शनल टू, जो भी फ्लक्स यहाँ पे पैदा हो रहा है दैट इज डायरेक्टली प्रोपोर्शनल टू द करंट which is already passing, right? So we can say that n phi is equal to what, the mutual inductance into I, where m is mutual inductance, means the ability of the second coil to induce a current due to the current in the first coil. So यहाँ पर जो बात कर रहे हैं अपन करंट, यहाँ पर किसकी वजह से, कहाँ पर एक्चुअली करंट इज इन द फर्स्ट कॉइल, और जो फ्लक्स क्रिएट हो रहा है वो फर्स्ट कॉइल के अंदर क्रिएट हो रहा है, लेकिन उसके अंदर एक और कॉइल होने की वजह से फ्लक्स यहाँ पर किसकी बात हो रहा है, फ्लक्स है यहाँ पर सेकेंड कॉइल की बात हो रहा है ना। तो सेकेंड कॉइल की जो फ्लक्स है दैट इज डायरेक्टली प्रोपोर्शनल टू द करंट इन द फर्स्ट कॉइल, क्योंकि करंट अगर ज्यादा है तो ज्यादा फ्लक्स पैदा होगा, और वो फ्लक्स सेकंड कॉइल में भी होगा क्योंकि सेकंड कॉइल उसके अंदर है। सो दिस m कैन बी रिटन लाइक म्यूचुअल इंडक्टेंस ऑफ द सेकंड कॉइल विद रिस्पेक्ट टू द फर्स्ट कॉइल। सो आई विल बी राइटिंग इट द होल वैल्यू n phi, तो n2 mu naught n I1 pi r2 square is equal to m21 I1. So I1 cancels, and you are getting a value for m21. You are getting a value for m21. M21 is equal to mu naught. This n2 I can write n1 n2 I can write n2 is equal to n2 into L, or pi r2 square. So mu naught n1 n2 into volume, actually it is pi r square is the area and L is the length. So length into area is a volume. So even you can write L into pi r square, or even you can convert this formula n1 is equal to capital N1 upon L, or n2 is equal to capital N2 upon L. So 1 L and 1 L cancel. So you can even write it mu naught capital N1 capital N2 or pi r2 square divided by L, because 2 L's will come in the denominator, so 1 L will cancel. So divided by L also you can do it. So here you have derived the mutual inductance formula for the second inductor, या second coil, या second solenoid, and it could be a coil, it could be a solenoid, second solenoid with respect to the first solenoid. So mutual inductance of the second coil with respect to the first coil is, it depends on the magnetic permeability, it depends on the number of turns, कितना closely वो wound है, तो per unit length में ज़्यादा number of turns हो गया, थोड़ा loosely wound है तो per unit length में कम number of turns होंगी, and it also depends on the length, and it also depends on the area of cross section. So greater area of cross section has greater inductive power, mutual inductance का power ज़्यादा है। तो यहाँ पर mutual inductance का सही मतलब अगर आपको समझना है तो the meaning of mutual inductance is this actually, कि there is a coil in the there is a current in the first coil, and the current in the first coil can induce a second current, a different current, a new current in the second coil due to the magnetic flux which it creates, and that magnetic flux relates to it goes through the second coil. Okay, so the first coil creates its own magnetic field due to the current, and that magnetic field can create a new current in the second coil if the magnetic field is varying, and it is surely varying when there is zero current, and when there is a high current there is a momentary varying, because 0 to I that is a variation of current. In the same way, there is a 0 to 5 is a variation of flux. So suddenly there is a flux means there is a variation of flux, and there is a momentary current induced, and we are talking about that momentary current right now. लेकिन अगर आप लगातार अगर फ्लक्स को वेरी करेंगे, अगर एसी करंट इसमें से मतलब पास करने देंगे, तो एसी करंट इज ऑटोमेटिकली वेरिंग एवरी टाइम. So then automatically in the second coil there will be a another varying current produced due to the first current there. So then the second coil will, without any physical contact, the second coil can induce some current, and that inductive power depends on the mutual inductance. These all factors. That's what we derived here. Okay, so let's go for the next topic, that is self-inductance. So इनका कोई यूनिट होता है म्यूचुअल इंडक्टेंस और सेल्फ इंडक्टेंस का, और जब मैं when I will be teaching you about the self inductance, I will explain you what is the unit. So you can go for the individual units also even and find out the unit for it. So let me explain you. Okay, the another part of this derivation also let me explain you before going into mutual induction, and that part is the other part of this derivation is if suppose there is a current through the second one, then what about the induction happening in the first one? Because now we have discussed about current passing through the first one and a current is induced in the second one, and now let's discuss on if the current is passed through the second one, and what is induction, what is the inductive power of the first one. So this is a mutual inductive power of the second one with respect to first one, which is called mutual inductance of the second coil with respect to first coil. And let's find the opposite, mutual inductive power of the first coil with respect to the second coil. So for that again the similar concept we are going to use. So the final answer I am not deleting here. So let me keep the final answer to compare with the answer we will be getting right now. So what is the flux through the first one? Due to current in the second conductor. So suppose I am passing a current I2 in the second conductor. I1, I2 is just to differentiate between the current of first and second. तो ये simultaneous current नहीं है ना, पहले I1 तो फर्स्ट कंडक्टर में पास किया, वो एक्सपेरिमेंट खत्म हुआ, and now a different current we are passing through the second conductor I2, the second conductor, and the current is I2 here. So N1 into phi का formula है B dot A. So B's magnetic field is due to the second conductor and area is its own, the bigger one. लेकिन हम जानते हैं कि ये जो छोटा वाला जो है वो मैग्नेटिक फील्ड जो पैदा करेगा, सोलेनॉइड में हमने ये सीखा, द मैग्नेटिक फील्ड एक्सिस्ट इनसाइड नॉट आउटसाइड. आउटसाइड में नेग्लिजिबल मैग्नेटिक फील्ड है. So if there is a current flowing in this direction, then the magnetic field is inside only, not outside. So in this also you have to find the same second area only. क्योंकि अभी छोटा ये जो स्मॉलर सोलेनॉइड है and it has a magnetic field, and the magnetic field is created only inside, not outside. So magnetic field still is only this much magnetic field. So इसके अंदर से magnetic field पास करेंगे तो ये पूरा भर जाता है, और लेकिन छोटे वाले के अंदर से magnetic field करेगा तो सिर्फ वही भरेगा. So यहाँ पर area, even though we are finding the flux of the first conductor, but still we have to put the area of the second conductor only, because field exists only in that area. So we will be writing N1 into B2 is mu naught N2 I2 into E2. So even we can write here N1 upon L mu naught into I2 into N1 into L. Area is pi R2. So this is the flux in the first conductor due to the current flowing through the second conductor. Then the question is, what is, by induction we can say that the flux is directly proportional to what? The current. Flux in the first conductor is proportional to the current in the second conductor, because their the current through the second conductor only create the flux. So N15 is equal to M12I2, means mutual inductance of the first conductor with respect to the second conductor. So N15 I am going to put it here, N1 into L, N1 into mu naught N1 into L pi R2 square is equal to M12 I2. Or here I2 is also there. So I2 cancels. Again you are getting M12 is equal to mu naught N1 into L pi R2 square. Mu naught N1 into L pi R2 square. So the area is still, we are considering whether it is the bigger one or the smaller one. Area is always for the smaller one also only. So both are the same. The answers are same. So we can write M12 is equal to M21 is equal to M. Simply you can write. So we can write therefore M12 is equal to M21 is equal to M. Mutual inductance. Simply we can write mutual inductance. और ये म्यूचुअल इंडक्टेंस जो है चाहे सेल्फ इंडक्टेंस हो या म्यूचुअल इंडक्टेंस हो, it is measured in a unit called Henry, in the honor of Henry, a scientist and who did experiments on this electromagnetic induction. Faraday and Henry, both of them. So and Faraday, we have already learned capacitors. Capacitors, the unit of capacitance is Farad, in honor of Faraday. Or in honor of Henry, we write it here, Henry itself, H, capital H. Henry is a unit of magnetic, mutual inductance. Mutual inductance. So this is actually mutual inductance. So let's go with self-induction. What do you mean by self-induction? So self-induction is there is a coil and you pass a current through the coil and it has a radius R and there is a flux created inside. So N into phi. Phi is B dot A. B cos theta. Cos theta is being 0 here because magnetic field is inside and area is. So B and A are perpendicular. B and A are here parallel because area का जो direction है वो भी ऐसा है perpendicular. Area का direction हमेशा perpendicular होता है area से. So B भी ऐसा है. So दोनों का direction same है. So we don't have to worry about the direction here. So B is mu naught Ni into area. So area even you can write pi r square. So B is mu naught Ni and the area is pi r square. And instead of N you can write N into L mu naught Ni pi r square. So this is a flux through the conductor itself. Because whenever there is a current and there is a magnetic field created and the magnetic field और मैग्नेटिक फील्ड की वजह से एक मैग्नेटिक फ्लक्स यानी नंबर ऑफ फील्ड लाइंस उस कॉइल के अंदर से पास हो रहा है, लेकिन एकदम से कॉइल में क्या हुआ, एक नया मैग्नेटिक फील्ड आ गया ड्यू टू करंट. सो देयर इज अ चेंज इन मैग्नेटिक फील्ड एंड चेंज इन मैग्नेटिक फील्ड विल कॉज एन इंडक्शन मींस ए न्यू करंट टू बी इंड्यूस्ड, ए न्यू ईएमएफ टू बी इंड्यूस्ड इन द सर्किट व्हिच अपोजेस द कॉज ऑफ प्रोडक्शन. कॉज ऑफ प्रोडक्शन यहाँ पे क्या है कि नया करंट आया. सो नया करंट आया तो उसको अपोज करने वाला एक करंट यहाँ पे पैदा होगा. नया ईएमएफ है तो उसको अपोज करने वाला एक ईएमएफ पैदा होगा व्हिच इज कॉल्ड बैक ईएमएफ. सो देयर इज ए इंडक्शन हियर and a new current will be induced, but the new current induced will depend on the flux and the flux will depend on the current which you are already passing. So that is very clear. N phi is proportional to I here because all other things are constants. So we can simply write N phi is proportional to I and N phi is equal to Li, where L is a सेल्फ इंडक्टेंस ऑफ द कॉइल. क्योंकि खुद का करंट की वजह से एक मैग्नेटिक फील्ड, एक मैग्नेटिक फ्लक्स को वो इंड्यूस कर सकता है और वो मैग्नेटिक फ्लक्स जो इंड्यूस हो रहा है वो करंट के ऊपर डिपेंड करता है, लेकिन खुद का कुछ प्रॉपर्टी के ऊपर भी डिपेंड कर रहा है, नंबर ऑफ टर्न्स के ऊपर डिपेंड कर रहा है, लेंथ के ऊपर डिपेंड कर रहा है, एरिया के ऊपर डिपेंड कर रहा है। सो इसके खुद के प्रॉपर्टी के ऊपर भी है। सो ये सारे करंट के अलावा जो प्रॉपर्टी है उसको मैं एक्चुअली एल लिख रहा हूँ, दैट्स ऑल एक्चुअली हियर टॉकिंग अबाउट। सो ये दोनों इक्वेशन को अगर मैं कंपेयर करूंगा तो आई विल गेट म्यू नॉट एन स्क्वायर I pi r square L is equal to Li. So you are getting L is equal to mu naught n square L pi r square, or you can write mu naught n square L area. Yeah, mu naught n square into volume. So mu naught n square into volume. So mu naught is a magnetic permeability here, and n is the number of turns per unit length. तो कितना क्लोजली बाउंडेड है, कितना लूजली बाउंड है, और लेंथ इज द लेंथ ऑफ द सोलेनॉइड हियर, एंड एरिया इज एरिया ऑफ क्रॉस सेक्शन ऑफ द सोलेनॉइड. सो दीज ऑल थिंग्स कंट्रीब्यूट टू व्हाट द इंडक्टिव पावर, फ्लक्स क्रिएटिंग पावर ऑफ द particular given conductor या given solenoid. So this solenoid is known as inductor because it can induce a new EMF. It can induce a new current. That's why. So let's here SI unit of inductor you can simply write again what Henry, and it is measured in H. So normally मिली हेनरीज में होता है, जो एक नॉर्मल कॉमर्शियल जो इंडक्टर्स मतलब कॉमर्शियली अवेलेबल जो है वो मिली हेनरी में, बट वट एवर द वैल्यू इज इट डजंट मैटर फॉर अस व्हेन देयर इज अ क्वेश्चन गिवन. सो इवन एम म्यूचुअल इंडक्टेंस भी ऐसा था, म्यू नॉट वहां पर दो डिफरेंट था, एन स्क्वायर की जगह n1 इंटू n2 था, और L तो था ही, और एरिया ऑफ द स्मॉलर वन इनसाइड वन था वह. तो यहाँ पर एक ही है और ये खुद अपने अंदर एक नया करंट को पैदा कर रहा है. सो सेल्फ इंडक्टेंस है, सो नेम इटसेल्फ इज सेल्फ इंडक्शन. खुद का मैग्नेटिक फील्ड की वजह से और खुद का मैग्नेटिक फील्ड चेंज होने की वजह से खुद के अंदर एक नया करंट पैदा होगा, नया ईएमएफ पैदा होगा विच इज कॉल्ड बैक ईएमएफ. और इसका अगर कोई सिंपल एग्जांपल मैं बताऊं, व्हेनेवर आप एक हेवी इंस्ट्रूमेंट का एसी और अदरवाइज हेवी मोटर कोई भी ऑन है ऑलरेडी आपके घर पे, एंड यू आर स्विचिंग ऑफ इट, तो जैसे आप स्विच ऑफ करेंगे तो उसमें एक स्पार्क दिखाई देगा. वो जो स्विच थोड़ा स्पार्क करेंगे, स्पेशली व्हेन यू आर रनिंग अ मोटर टू pump water from the underground tank to the overhead tank. So that one comes in almost 1000 watt, 1 kilowatt. So high power rating wala ek instrument hai. And the iron box, that is also a high power rating instrument. So when a high power rating instruments are connected and it's already running and you are switching off it, and suddenly there is a spark you can see in the switch there. उसका सिंपल रीजन है, इसीलिए इन सब का स्विच थोड़ा सा बिना स्पार्क करने वाला नॉन इंडक्टिव स्विचेस आते हैं थोड़ा सा अलग से, है ना. अगर आप नॉर्मल स्विच में अगर आप इसको कनेक्ट करेंगे तो आप देख सकते हैं नॉर्मल स्विच को आप ऑन ऑफ करते हैं तो उस वक्त एक स्पार्क दिखाई देगा. एंड द रीजन ऑफ द स्पार्क इज ड्यू टू द मोमेंटरीली इंड्यूस्ड ईएमएफ, इंड्यूस्ड करंट ड्यू टू सेल्फ इंडक्शन. और सेल्फ इंडक्शन यही हो रहा है कि आपने एकदम से करंट को बंद कर दिया, तो वहां पर पहले ऑलरेडी मैग्नेटिक फील्ड था एंड सडनली द मैग्नेटिक फील्ड वैनिश्ड. सो देयर इज अ चेंज, देयर इज अ बिग चेंज इन द मैग्नेटिक फ्लक्स, एंड द चेंज इन द मैग्नेटिक फ्लक्स विल इंड्यूस ए opposite current, and the current tends to oppose the cause of production. So that is what happening there. That is due to that, and there is a new current induced, and a new current causes spark in the switch there. So that is all about self induction. और ये सेल्फ इंडक्शन से चलने वाले कई डिवाइसेस है, चॉक in the tube lights, and in that there is a coil and there is an inductor, I should say. So this solenoid itself is known as, actually coil itself is known as ये इंडक्टर, और इसके ऊपर और भी कितने भी वाउंड हो सकता है. सो इन द सेम डायरेक्शन में अगर वाउंडेड है तो देन दैट इज ए गुड इंडक्टर. अगर ऑपोजिट डायरेक्शन में और वाउंडेड है तो फिर वो इंडक्शन कैंसिल हो जाएगी. एनीवे, सो लेट्स गो विद द नेक्स्ट टॉपिक, दैट इज द एनर्जी. How this inductor behaves like an electrical inertia, and we are going to find out the energy of the inductor. So अभी ये इंडक्टर का सिंबल कैसे बनाएंगे, अपन सिंबल ऐसे बनाएंगे. So this is a symbol for inductor, and this is a symbol for capacitor, and this is a symbol for resistor. So these are the symbols and the representation of three devices which we have learned so far. And the first device we have learned was resistor, even in smaller classes. But in this unit, actually first device that you learned was capacitor, and then you learned about resistor. And now you are learning about inductor. Resistance is measured in ohm, and a resistor has a resistance measured in ohm, and capacitor has a capacitance measured in farad, ohm, farad, and Henry. All are the names of scientists, and the units are given in the honor of these scientists actually. So resistance is measured in ohm, and capacitor and capacitance. Capacitance is its ability to store charge. Resistance is the ability to resist the flow of current, and inductance is the ability to induce a new current. Induce a back current. So that is measured in Henry, and this is measured in farad. Microfarad normally we write, this is measured in ohm. So this ohm can be, ohm is always getting higher values only, because we require high resistances. Okay, so these are the three new electrical devices we are learning, and we have more devices in the later sections, like diodes, transistors, or in that few things are actually already omitted from the syllabus. But in this chapter actually nothing is omitted, so let's discuss with all these things. So self-inductor behaves like an electrical inertia. How will you explain? So if current is flowing through the inductor, so whenever the current tends to change, then the magnetic flux change. So suppose current tends to increase, so only 2 ampere current is flowing, but the current increases to 4 ampere suppose within 10 seconds. So when the current induces to 4 ampere or 5 ampere or whatever, when the current suddenly increases, what happens is the flux changes, flux also increases, and whenever there is flux change, then there is an opposite current. So current increase हो रहा है तो opposite current उसको क्या करेगा, उसको कम कर देगा. So increase करने से अगर flux change हो रहा है तो increase करने के बजाय decrease करेगा. So there is opposite current. And suppose the 2 ampere suddenly reduced to 1 ampere, so there is a decrease. So whenever there is a decrease, the flux changes. The flux changes, then new current is induced. So new current opposes the cause of production. New current opposes the cause of production means it will oppose the decrease. So अगर decrease को oppose करना है तो same direction में current को flow कराएंगे, ताकि जो 2 एम्पियर से 1 एम्पियर में जा रहा है वो 1 एम्पियर से वापस 2 एम्पियर में आ सके. उस लायक एक नया करंट को ये इंडक्टर खुद प्रोड्यूस करेगा. So it means that the inductor tends to stabilize. It tends to inertialize the current there. क्योंकि inertia क्या चीज होती है? It does not want to change its state of rest, change its state of motion, and change its direction. That is what we learned about inertia of motion, inertia of rest, and inertia of direction. And the property by virtue of which it does not want to change its direction या rest or motion. So अपनी state को change करना नहीं चाहता. In the same way, here inductor does not want any change in the current, because change in the current will induce a new EMF, and the new EMF will oppose the cause of production, means oppose the change in the current. So the electrical, it acts like an electrical inertia. It does not want to change the current. So if you want to stabilize the current in the circuit, you can connect an inductor in a series. So a current connecting an inductor in a series means there will not be much fluctuation in the output current. So let's go with the formula we already have. N phi is equal to Li. That's the formula we have. Because N phi is proportional to I. The flux through the inductor is directly proportional to the current passing. So proportional को equal में convert करेंगे तो constant डालेंगे, that is a inductance, self inductance. Or then according to the Faraday's law, E is equal to minus d phi by dt. So we can write over here A is equal to minus d by dt of. So यहाँ पे d phi जो है, it is a total flux actually. So we have to properly write n phi by dt. That is the total flux. So Li by dt will be so minus L di by dt. So that is a EMF induced in this inductor. A back EMF induced, a new EMF induced due to the change in the current. So if there is no change in the current, no extra EMF is induced. So if a DC current is flowing through this and you are not changing the current, so because DC is a steady current, but AC is a fluctuating current always, and it has a maximum value and minimum value, maximum value, minimum value, just like oscillation. ना oscillation में एक mean position में आता है, फिर उसका value बढ़ता जाता है, displacement का value, फिर कम होके जीरो आता है, फिर value बढ़ता जाता है. So oscillating, अगर कोई oscillating current है, उसका value oscillate हो रहा है 1 second में 50 times, that is the oscillation of the current which is in India, है ना. 50 hertz हमारे जो current supply आ रहा है, इसका जो oscillation है या ये जो AC current है, इसका जो frequency है 50 hertz बोलता है. 50 hertz का मतलब है कि 1 second में 50 बार ये ऊपर नीचे जाते रहता है. So that's what the meaning is. उसका वैल्यू चेंज होते रहता है, लेकिन वो फास्ट चेंज हो रहा है इसलिए पता नहीं पड़ रहा. 1 सेकंड में 50 बार तो कहाँ से पता पड़ेगा. So we have here E is equal to minus L di by dt, and we already know what is a formula for power. The power dissipated, the power diluted, the power in the power of the the electrical power which is flowing through the circuit is E into I, yeah, V into I. And I can write here instead of E minus L. So I am only writing the magnitude L di by dt because minus represents, it opposes the cause of production. Current increase हो रहा है तो decrease कराने की कोशिश करेगा, और decrease हो रहा है तो increase कराने का कोशिश करेगा. So that is what minus represents here. And so power, I can write the rate of doing work is power, Li di by dt. So I can cancel this dt's, and I can cancel this, remove this dt's, and I can write dw is equal to Li di. So if I integrate this, I will be getting, so integration dw is equal to integration Li di. So work का integration total work होगी, है ना, total work done to increase or decrease the current, and that is equal to what you are getting, L I di. So I di का integration होगा, I की power 1 है तो I square upon 2, x raised to n का integration होता है x raised to n plus 1 upon n plus 1. So that is a work done, and this work done gets stored as a potential energy, half Li square, and which is similar to the concept of kinetic energy, half mv square. So if something is moving with a velocity v, then the kinetic energy is half mv square, where m is a inertia of mass, and here potential energy of the inductor is half Li square, where L is the inductance and I is the current passing through it. So if the current is flowing through it, then it has a potential energy there, and that is half Li square. So L must comparable with mass. So mass अगर inertia है तो L भी यहाँ पर inertia है. So mass यहाँ पर एक weight के हिसाब से, mass के हिसाब से inertia है. इसलिए L यहाँ पे electricity का flow के हिसाब से, which we call as electrical inertia. So there is electrical inertia and there is a inertia of mass. So even then now we have derived the potential energy. It's similar to another formula that we learned already, capacitor में half CV square, where C was the capacitance and V was the potential difference. So when there was no flow of current there, because only potential difference due to the two static charges there. Two types of charges. One type is on the one plate and another type is on the plate. The charges are standing there and there's a force of attraction between them, and capacitor stores charge. So it's the ability to store charge anyway, capacitance is. So charges are there, and due to the charges it has a potential energy half CV square, because there is electric field existing between them, and there is a potential difference existing between them due to the charges. Positive charge and negative charge, so negative potential, positive potential. So anyway there is a potential difference. In the same way for inductor, there is a current through the inductor, then there is a flux. If there is no current, no flux, because B is equal to mu naught Ni. That's what we derived for solenoid. So mu naught Ni है, तो वहाँ पर अगर I है तो mu naught Ni मतलब B मैग्नेटिक फील्ड भी है, और मैग्नेटिक फील्ड है तो फिर वहाँ पे फ्लक्स भी है, क्योंकि phi is equal to B dot A है. So इसका खुद का कोई एरिया तो है ही. So there is a flux. A number of turns है तो n phi हो गया. So n into B into A. So these all things we have already done. तो इसका मतलब है कि whenever there is a current in the inductor, there is a flux induced. And the flux, if it change, then it can induce a new current. So why it can induce a new current? Because the flux contains some energy. And without energy, you cannot produce a current. So that energy, the magnetic flux, which holds the energy, is this half Li square. And even you can convert it into the magnetic field, because L का value आप पहले से जानते हैं, और I का value B is equal to mu naught Ni में I का value B में convert करके आ जा सकता है, और L का value जो हमने derive किया वो इसमें डाल सकते हैं, and you can even convert it into a different form. So how to convert it into a different form, you see. So U is equal to half L. So instead of L we can write mu naught N square pi R square, मतलब area into L. And I square is I का value. So I'm writing, but I is equal to mu is equal to mu naught Ni. So I is equal to B upon mu naught N. So I can write U is equal to half mu naught N square AL into I square B square upon mu naught square N square. So N square cancel. 1 mu naught and 1 mu naught cancel. And you are getting U is equal to half into B square into AL divided by mu naught. So we can write U is equal to half into B square upon mu naught into A, where area into length is a volume, because this is simply one inductor, one coil, to one coil का length और one coil का area तो fix है, so it is a volume. So volume को यहाँ पे divide में ले जाएंगे तो you can write even energy per unit volume is equal to half B square upon mu naught. It means the energy is stored in the magnetic field. The similar formula we have learned in chapter 1. Chapter 2, energy of a capacitor is equal to half, where in that it actually instead of B it was E square, और divide में mu naught है तो वहाँ में multiply में epsilon, half epsilon naught E square, that was the energy density of a capacitor, and this is the energy density of a energy per unit volume, energy density of a inductor, energy density of an inductor, energy density of a solenoid is this half B square upon mu naught, क्योंकि area into L the volume divide में आ जाएगी. So this is the energy density. So this is actually the derivation, and ये example में दे रखा है आपकी book की. So this is a XII plus example. come a question है, and it is both concept and derivation. So it means we have got a new device which again stores energy like a capacitor, but it stores energy in the magnetic field, and using that energy it can induce some new current, a back EMF it can create, which opposes any change in the current which is already flowing through the circuit. So if a current is flowing through the circuit, there is a magnetic field induced, and the magnetic field stores energy. That's what the idea all about is. So magnetic field stores energy, electric field stores energy. Then in the 8th chapter you will be learning about a new concept called electromagnetic field. So if magnetic field stores energy, electric field stores energy, then it can it can exchange the energy from electric field to magnetic field and magnetic field to electric field. So the energy goes on like like you have learned in rarefaction and compression. A sound wave is produced and energy moves from rarefaction to a compression and compression to a rarefaction, and your sound energy can move from one place to another. In the same way, the electrical energy can move in the form of a wave, in the form of an electric field and magnetic field, and again electric field and magnetic field. So it creates an electric field which creates maybe a magnetic field. A magnetic field may be creating another electric field. So it is the energy is moving from one place to another. That's what actually we are doing right now. क्योंकि आपके मोबाइल का कम्युनिकेशन हो रहा है, इंटरनेट का कम्युनिकेशन हो रहा है, जो भी एयर में जो कम्युनिकेशन हो रहा है, दैट इज ड्यू टू द इलेक्ट्रोमैग्नेटिक वेव्स which is produced by your mobile going into the tower, which is produced by the tower and coming into your mobile, so that the communication is established there with the help of electromagnetic wave, which are actually electricity only, but in a different form, electricity in a wireless form. So those things we will be learning anyway later, but here we have something to compare with electric field and magnetic field. Electric field and magnetic field का जो अधिकतर derivations और अधिकतर theories जो है बहुत ही ज़्यादा similar है. They are very much close to one another, very much similar to one another, and they are even related to, as we have learned, electricity can create magnetism, and here now we are learning the magnetism can create electric current. Whenever there is a change in the magnetic flux we are related to a coil, then an EMF is induced in the coil. That's what we have learned. Okay, so that's all about the self-induction and the energy of an inductor. And now let's go with a new topic. So the next topic is AC generator. So what is an AC generator? Let me explain you. There's a north pole and there's a south pole, and there's a rectangular loop, but it's a coil actually with n turns, but for the purpose of learning I'm putting it only as a loop. So rectangular loop, and this loop has some rings. With a brush, with another brush, this is spring, and which make them to stay very tight with these rings. So these are called actually slip rings. This is carbon brush, and the carbon brush and slip rings are not connected with each other actually. These springs are connected to the frame of the generator, and the spring pushes this carbon brushes and keeps it in contact with this slip rings. So slip say if you press, if you push this carbon brushes, will get away from the slip ring, means it will not touch the slip ring. But due to the spring and spring exerted force on the carbon brushes, and it just gets in contact with the slip rings. So one slip ring is attached to one end of the coil and other slip ring is attached to another end of the coil. But actually this entire thing has a big shaft over here. और इस शाफ्ट के अंदर से ये दो कनेक्शन आती है, लेकिन मैंने अभी शाफ्ट वगैरह ड्रॉ नहीं किया, ओनली आपको कनेक्शन दिखाया है. सो when you are rotating this coil ABCD, what happens in this coil when it is placed in a strong magnetic field, north to south pole, there is a magnetic field existing here. So a conductor which is placed, a coil which is placed in a magnetic field, when it is rotated, what happens with the flux? Because we know that EMF is equal to the rate of change of flux. And what is the flux here? Flux का formula है n phi का formula है phi का b dot a, so ba cos theta, that's the formula. So what is changing here? The B is in this direction and the area of the loop is in this direction. When you are rotating the area of the loop, the area is not decreasing, but the direction of the area, cos theta, is changing. So cos theta is a variable, so you can write NBA and you can write even minus NBA d upon dt of cos theta. But here the variable is different. Here is theta and here is t. So we can go for theta is equal to, displacement is equal to velocity into time. Angular displacement is equal to angular velocity into time. Because angular velocity is equal to theta by t. So we can write here minus NBA d upon dt of cos omega t. So instead of cos omega t, minus NBA cos omega t का differentiation होता है minus sin omega t multiplied by omega. So the final answer to this derivation is EMF is equal to plus NBA omega sin omega t. So you see here there is an EMF induced because there is a variable which makes the flux to be a variable, that is a cos theta. So when you are rotating this armature, when you are rotating this entire coil with the help of this shaft, when you are rotating it, the slip rings are being rotated, but the brushes are not being rotated because brushes are not connected to slip ring. It is only in contact due to the brushes. Brushes are pushing them, so the slip rings are slipping over the brushes. So इसका नाम इसलिए slip ring है, they are slipping over the brushes, and what happens is that EMF is induced in the coil. And EMF is induced और EMF का direction जो है ये सब आप Fleming's right hand rule से इसमें जो करंट का डायरेक्शन है वो फाइंड कर सकता है, फोर्स फील्ड एंड करंट. सो यहाँ पर जो फोर्स है, अगर आप ऊपर की तरफ कर रहे हैं, फील्ड उस डायरेक्शन में है, तो फोर्स ऊपर की तरफ है, फील्ड उस डायरेक्शन में, तो करंट विल बी योर मिडिल फिंगर, मतलब करंट विल फ्लो फ्रॉम A to B and current will flow from C to D for the other one because it is coming down. So there is a continuous current A to B and C to D. So there is a current like this. But why it is alternate? Because after half cycle, this AB goes here. So when the AB comes here, then in the AB, the current flows in this direction and CD in this direction. But AB comes here, then when AB comes here, the current flows down. Means current flows from, suppose here it is AB, here it is AB. Then current flows from C to D, like B to A, but here A to B. So when the part AB is on the north side of the pole, means towards the north pole of the magnet, then current flows from A to B. When it is towards the south pole of the magnet, then current flows from B to A, means the current reverse its direction. So after every half cycle, current reverse its direction. You can even show it like this on the graph. The current is like this and then current is like this. And why it current reverse, even you can go for this formula. When it is 180 degree, the current has the same value because we know that sine 180 is 0 and sine 0 is 0. So this is 0 degree and this is 180 degree. But so when 0 to 90 the value of sine increases, then 90 to 180 the value of sine decreases, and then at 180 sine is 0. And then after 180 means in the third and the fourth quadrant, when the angle is between 180 and 360, the value of sine is negative, because in third and fourth quadrant y-axis is negative, so value of sine theta is negative. So value of sine theta is negative. It means that value of sine theta is negative. What does it mean? It means that this EMF is negative, so negative EMF, but still it is increasing and then decreasing. So you see an alternating current, it reverses its direction and it also changes its value continuously, because sine theta changes value continuously. So it is increasing continuously and decreasing continuously, then increasing continuously and decreasing continuously, but in the opposite direction. So the current is moving like this and again moving like this, moving like this and moving like this. So current is reversing its direction. That is why it is called an alternating current. And also its value changes. So definitely this type of alternating current can cause induction, because whenever there is a change in the current, then there is an EMF is induced. It can cause a new EMF even, because in the coils it can induce new currents. So we'll be learning about AC current in detail in the next chapter, chapter 7. So chapter 7 is mainly talking about AC current only, and how we can connect a capacitor, resistor and inductor to an AC source. And so far we were learning about DC, direct currents, and जो भी हमारा formula है वो सारे direct current से related formula था. But now we have learned a device which can produce a DC AC current, alternating current, a current in this form, because the formula that we get for EMF is NBA omega sine omega t. And here suppose I am going to take the maximum value at 90 degree. Maximum value is NBA omega, which I can write epsilon naught या E naught sine omega t is maximum. So I can write E is equal to E naught sine omega t. So there is a maximum value in the graph for the EMF, and that is called E naught. The maximum value is called E naught. So E is equal to E naught sine omega t. Maximum value multiplied by sine theta, yes, sine omega t, where omega is the angular frequency. There is a particular frequency with which we can rotate. Even you can convert it into linear frequency. Omega is equal to 2 pi nu, yeah, f, 2 pi nu t. So there is a frequency called nu, and you may be rotating it 50 times per second. हो सकता है 1 सेकंड में 50 बार घुमा रहे, या 1 सेकंड में 10 बार घुमा रहे, 1 सेकंड में 8 बार घुमा रहे. So whatever it is, that nu is a frequency. So you can put the value of nu, and at different time interval, yeah, different time the EMF is at a different value. So that's what here the EMF is fluctuating. So when the EMF is fluctuating, automatically the current also will fluctuate. So the current also will have the same type of movement. So in the next chapter we will be learning about the relation between the EMF and current, and what is the relation between EMF and current in an inductor, relation between EMF and potential difference and current in a resistor, potential difference and current in a inductor and capacitor, all these things. And there is even a circuit called LCR series circuit and a connected circuit. So all these things we will be learning in the next chapter. So this chapter is ending with a new concept called AC current, which is actually the next chapter is all about. So the chapter comprises of a very clear idea. That idea is electromagnetic induction. The change in magnetic flux can create electric current, and the change in magnetic flux can be caused by changing the number of turns. You cannot anyway change. You can change the magnetic field, you can change the area, you can change the cos theta. So by changing the area, we have already learned. By changing the area, That was actually the Marshall EMF, the first derivation. And now we learned about by changing the cos theta, the angle between magnetic field and area, you can induce an EMF. Means you can change the flux. So change in the flux by Faraday's law. Whenever there is a change in the flux, an EMF is induced. A new current is induced in the coil. So that's all about the chapter. So you can do the numericals, you can do the word problems, and the word problem to this chapter is very important.